All right, guys, so what we're looking at today is inverse matrices and systems of equations. This is the last thing we're actually covering in chapter 4.6 of the Green Book, or 4 of the Green Book. Now, be able to identify an inverse. If two matrices are inverses of each other, their product will give us what we call the identity matrix. An identity matrix is just a matrix with a diagonal of ones and everything else is zero. This here is considered the identity for a 2 by 2. Now a 3 by 3's identity matrix will still have a diagonal of ones. It's just going to be a 3 by 3. We'll just have them going straight down the center, going from left to right. It's going to be considered the identity matrix. And then whenever we multiply the matrix by the identity, we get the matrix back. Because if we multiplied the identity matrix, and this isn't in your notes, but say 1, 0, 0, 1, by 4, 7, negative 3, 2. Because when we did the multiplication, we would go over and down. Well, here we would have 1 times 4, which is 4, plus 0 times negative 3, which is just going to be 0. If we do it again, over and down, well, we would have 1 times 7 plus 0 times 2. And if we do it again on the bottom row, so we go over down, well, it would be 0 times 4, which is 0, plus 1 times negative 3, which is just going to give us negative 3. And if we do the last one over and down, well, 0 times 7 is 0, and 1 times 2 is plus 2, which will tell us that we would have 4, 7, negative 3, and 2, which is actually the matrix we started with. This one here, multiplying by the identity matrix, would be the only time we can multiply by the left and the right and get the same thing. Now, and that's essentially what this is saying. We can multiply by the left and right and still get the same thing. Now, it's also said that two matrices are considered to be inverses if their product is the identity matrix. If we can multiply the two together and get the identity matrix, then the two matrices are inverses. So here we do negative 4, 2, negative 2, 1, and multiply it by 1/4, 1/2, negative 1/2, and negative 1. If we multiply these two together and get the identity matrix, then the two matrices are inverses. So our first over and down are going to be these here. So we're going to have negative 4 times 1/4 plus 2 times 1/2. We'll do the same thing again. We'll go over and down for our next one, which will be negative 4 times negative 1/2 plus 2 times negative 1. Now we could do the next multiplication, which would be over and down, which would be negative 2 times 1/4 plus 1 times 1/2. The last one would be our over and down, which would be negative 2 times negative 1/2 plus 1 times negative 1. Any questions on this here so far? Now what we need to do next is simplify these here. Well, our first one, negative 4 times 1/4 is negative 1. 2 times 1/2 is going to be plus 1. Negative 4 times negative 1/2 is going to be 2. And 2 times negative 1 is negative 2. And our bottom here, negative 2 times 1/4 would be negative 1/2. Plus, well, 1 times 1/2 is 1/2. And the last one, negative 2 times negative 1/2 would give us 1. And 1 times negative 1 is negative 1. What would happen to every number in this? 0. So are these two inverses? Right, it's not the identity matrix, because if it was, then we would need this 0 and this 0 to both be 1. So this here, are these two inverses? Well, no, because we don't have the diagonal of 1. Any questions on this here so far? Well, we can always use the calculator to check this. Because we can go second matrix over to edit, and put the first matrix into matrix A. So we could say negative 4, 2, negative 2, and 1. So I can enter matrix A in first. Then we can go second matrix over to edit and edit matrix B, which would be a 2 by 2. And we'd have 1/4, negative 1/2, one-half, and negative 1. Now we could do the alpha y equals enter and plug them in as a fraction, or we can do them with the division either way. Now we can do the multiplication. So we can go second matrix A, second matrix B, and hit enter, and we get the 4 zeros. Since it's not the identity where we have the diagonal of 1s, it will not be an inverse. Questions on this here?
Are we allowed to not, or don't use the calculator on your homework, or do we have to show it?
You can use either one. Well, let's look at the next one. So we could do this by hand, or we can do it in the calculator. I have a feeling y'all want to do it in the calculator, yes? Okay. So if we look at B, the second one, so we can go second matrix over to edit and hit enter. Now our matrix is still a 2 by 2, and it would be 3, negative 5, negative 2, and 6. So that would be our matrix F. Now, second matrix over to edit, and we'll define matrix G in matrix B. We'll put it in there. And matrix G, so we could do alpha y equals enter and plug in 3/4. Alpha y equals enter will give us the fraction. And then we can do 5/8. Our next one, alpha y equals enter, and we can do 1/4. And the last one, alpha y equals enter 3/8. So we can use the alpha y equals enter to get the fractions as well. Any questions on how we type these in? So we can go second, quit. Now we want to do, well, matrix A times matrix B. Because we already had it there, so I can go in and just recall it. And if we hit enter, do we get the identity matrix? Yes. Let's go in and multiply them the other direction. So this time, let's do matrix B, matrix A. And if we multiply them the other direction, we still get the identity. Because if two matrices are inverses of each other, A times B is going to be the same as B to give us the identity. For any two matrices, if they are inverses, we can multiply them in any order and get the identity. Questions on this here? So this one here was no. But these two are, yes, they are inverses because their product gives us the identity. Is if any two matrices multiplied together to give us the identity matrix. So here when they multiplied, they gave us 1, 0, 0, 1. They will be inverses. Any questions on this here? Any questions on determining if two matrices are inverses? Okay. Now, we do have a formula for actually finding the inverse of A2 by 2. Matrix A, B, C, D. A to the negative 1 is telling us that's our inverse. Is going to equal 1 over AD minus BC. Is going to be multiplied by the matrix D, negative B, negative C, A. And AD minus BC cannot equal 0. If AB minus BC is 0, it's really telling us that the matrix is not invertible. We do not have an inverse. And really, this here should look familiar because that's our determinant of a 2 by 2. Because it's our diagonal going across one way minus the diagonal of the other. Any questions on this here before we find the inverse of P? So if we look at this here for the inverse of P, we're going to have 1 over this diagonal here, 7 times negative 1, minus the other diagonal would be negative 5 times 2. So really, that's just 1 over the determinant of matrix P. Now, inside the matrix here, well, there's a few things that are happening. One is that A and D switch places. The values for A and D flipped. So here, the value of A is, and the value of D is. So that means negative 1 is going first, and 7 is going last. Those two flip places. And the other two, we're just switching the sign, because we have negative B and, well, here B is positive 5. C is positive 2, so it's now at this point here, we just need to simplify this, and we're done. So the first thing we can simplify is the denominator here. 7 times negative 1 is negative 7, minus negative 5 times 2 is negative 10. But a negative and negative would make a positive. Here we still have negative 1, 2, 2, 5, 7. Well, negative 7 plus 10 is 3. Any questions on how we got to this here? And the last thing we need to do is multiply through by 1/3. So we'll have negative 1/3, negative 2/3, 5/3, and 7/3. Which makes this here, that's our letter P. This will be P inverse. And we put it to the negative 1 to denote that it is the inverse of P, matrix P. And this also means that if we multiply this here by the original matrix C, it'll give us the identity matrix. Questions on this here? Any questions on any of this here? We ready for the next one? Let's look at Q. So if we want the identity matrix, or the inverse, Q inverse, so we're going to have one really over the determinant of Q. So our 2 by 2 determinant is these two multiplied together, so negative 8 times 9, minus these two, which would be negative times 12. Now how would we go inside the matrix now? Our first number would be, and then, because our A and B, the negative 8 and 9, switch places, and our negative 6 and 12, we flip the sign. Any questions on how we set this up? So let's look at the fraction. Well, negative 8 times 9 is negative 72. Minus negative 6 times 12 is negative 72. Well, negative and negative make a positive, yes? Negative 72 plus 72 is? Can I have 1 divided by 0? No, this is not invertible or not possible. We can say not invertible or not possible. Either one works. So this one here does not have an inverse. So really, if I want to determine if a matrix E had an inverse, I just need to take, if I can scroll up, its determinant. Because if the determinant is 0, it doesn't have an inverse. If the determinant is 0, then it does not have an inverse. Questions on this here? So we could check that even before we started for, say, like 2a to see if it does work. Because if I look at this here, the determinant would be our cross. So that would be 3 times negative 4 minus 7 times 1. Well, what is 3 times negative 4? Negative 12 minus, well, 7 times 1 is 7, which gives us negative 19. So will 2a have an inverse? Well, yes, because the only way that it won't have an inverse is if the determinant is what? 0. Okay, so this will have an inverse, and we can find it. Because this is going to be 1 over negative 19. Because the fractional part of the inverse equation is just 1 over the determinant times the matrix. So we take the first and fourth term, 3 and negative 4, and we flip them. So we would have negative 4 and 3. The 7 is now negative 7, and 1 is now. And then we can multiply these two together. Negative 1/19 times negative 4 is 4/19. Negative 1/19 times 7 is 7/19. Negative 1/19 times 1 is, well, 1/19. And negative 1/19 times 3 is negative 3/19. And that there would be the inverse. Questions on this here? We ready to look at the last inverse that we're looking for, if it exists. Well, we can check the determinant before we do anything, because we'll have 2 times 3 minus negative times 1. Well, 2 times 3 is 6 minus, well, negative 4 times 1 is negative 4. Negative and negative make a positive. 6 plus 4 is 10. So will we have an inverse? Yes. Okay. Let's see if the calculator will do this. Well, the first thing we need to type in if we're doing this in the calculator is, well, the matrix itself. So we can go over and define matrix A as the given matrix. So we'd have a 2 by 2, and this would be 2, 1, negative 4, and 3. Now, once we get this typed in, we can go second quick because we only have one matrix, yes? Now I'm going to call the matrix up, second matrix A. Now, how have we been writing inverse, or how are they writing inverse with a what? It's been in there, hasn't it? Because inverse in matrix A is what? A to the negative 1, yes? Do we have that somewhere here? It's our matrix button, isn't it? Enter. Now, all of our answers so far have been what? Fractions. They gave us decimals, so how can we fix that? Math, enter, enter. So the inverse of this matrix is 3/10, negative 1/10, 2/5, and 1/5. And really, it's just telling us that the two denominators, the 2/5 and 1/5, had a common factor with 10 that caused it to reduce. Yeah, we'll go on and reduce it if we can. And really, if we're doing 3 by 3s, you're better off using the calculator to find them, because it's a little bit more challenging to actually do the calculation by hand. Any questions on this here? We'll stop here for today, and we'll finish this tomorrow.